When using Nina, and probably with other control software like Nina, it really is important to start off with a proper autofocus, especially if you're going to use a tool, something like 3-point alignment to line up your telescope, or plate solving to inform your telescope which way it's pointing when you start up the system, because those apps will not be able to plate solve unless you have a nearly perfect autofocus done already. And whether you're using a one-shot color camera or a mono camera with various color filters, you will need to redo focus through the night. Changing atmospheric conditions can create small but significant changes in focus. And if your focus isn't periodically redone through the night, you'll end up in the morning with soft images. As a general rule, I have Nina set to redo autofocus every hour at least. If I'm using a mono camera and LRGB filters, I'll have it redo autofocus every single time it changes filter. But running an autofocus sequence takes time, and for astrophotographers, time, especially during a clear night, is an extremely valuable commodity. So let's look at a few ways you can go about speeding up that autofocus sequence. I'll just start out by adding that for Nina users there is a plugin called Autofocus, which I very strongly advise downloading. It's very powerful and really speeds up focusing, but it's also a topic for another video. For now, I want to look at some ways of improving autofocusing that rarely ever seem to get covered. And because Nina is my control software of choice, that's what I'm going to use today. But I'm sure you can use the principles we're going to cover in other control software. So in Nina, if you go to the column on the far left and select the Options tab, and then just right of that, select the Autofocus tab, toward the bottom, you'll see an area labeled Autofocus Filter Settings. There, you'll find columns for position, name, focus offset, autofocus exposure time, binning, gain, and offset. Here you can customize the strategy that Nina's autofocus sequencing will use for each filter in your filter wheel. Let's look first at the binning column, since I think that's what most people adjust when they are changing around settings to try to improve autofocus. You probably know this already, but binning is a process where you get 2 or more pixels to act as a single pixel in your camera's sensor, and binning tends to improve SNR, or signal-to-noise ratio. In plain language, it gives you a clearer image. But it comes at the expense of effectively making your pixels larger. However, for guiding purposes, this isn't much of an issue. Often, it's important to emphasize your signal-to-noise ratio. Notice Nina gives you the option to adjust binning separately for each filter. This is very important because some types of filters really need some binning. With OSC cameras running UV IR cut filters or dual or tri-band filters, I don't really find binning necessary. Likewise, I don't find binning necessary for LRGB filters. So you can see in the autofocus settings that I have the binning for the LRGB filters set to 1x1. For those filters, each pixel will act as a single pixel. I think not binned is fine for LRGB filters, but that may only apply to my region. Please keep in mind I live in an area of Bortle maybe 1.5. If you're in an area with light pollution, you may find it useful to experiment. It's easy to do, just click on the box that lines up with whatever filter you want to adjust the binning for. Note that my last 3 filters, 5, 6, and 7 for HA, S2, and O3 all have 2x2 binning, which, as we covered, means that 4 pixels, 2 vertical and 2 horizontal, come together to act as a single pixel, or 4 pixels form a virtual single pixel. And this is especially necessary with those narrowband filters. Narrowband filters block a lot of light, so the light that does get through them creates a dim image. Therefore, even in a dark sky area like where I live, binning really becomes a necessity. To the right of the binning column is the gain column, and I find adjusting gain to be extremely useful for most filters. However, I've hunted all over the internet for information on adjusting gain for filters when autofocusing, and honestly, I couldn't find anything. I found a pile of articles on adjusting your binning and focus offsets for autofocus, but nothing on gain. So I just wanted to take a moment to cover gain. The gain here works exactly as adjusting the gain in your camera. For those of you who are new to astrophotography, gain is relatively the same thing as ISO, and you'll notice I'm sure that I have 3 different gain settings in this column. The number 1, or luminance filter, has a gain setting of 0. The luminance filter produces such a bright image that I don't find it necessary or useful to increase the gain any. Now the R, G, and B filters each block a lot of light, so I have their gain set at the camera's unity gain of 130. I have found if I didn't boost the gain for those filters, I would have to increase the exposure time. But generally, when autofocusing, you want to keep your exposure time down to the minimum possible. This is because the shorter you can make your exposures, the less possibility there is of guiding error being introduced into them. Guiding errors would soften the image, throwing off an autofocus sequence. So by raising the gain on the R, G, and B filters, I can keep the exposure time to 6 seconds, the same as my standard exposure time for the luminance filter. Bear in mind, you will have to customize these settings for yourself. Don't see my numbers as universal settings. You have to customize the gain according to your own camera and its settings, but also in regard to the light pollution and seeing in your area. Also, don't just keep amping up gain. It introduces other problems into the focus sequence. Try to avoid going above your camera's unity gain if possible. You'll notice in the bottom row, I have 250 gain set for the 03 filter. However, I like to experiment, and in this case, that's exactly what I was doing. Experimenting with some pretty wild gain and focus time settings just to see if I could maybe tease out better outcomes. In the end, I ended up going with a 130 gain and a 40-second exposure time for that filter. And I advise you also experiment. Play around with the settings and find what works best for you. Let's look at the middle column now, autofocus exposure time. As noted a moment ago, you always want the shortest possible exposure time because, among other things, it minimizes the possibility of guiding errors being introduced into your autofocus images. For the L, R, G, and B filters, I find 6 seconds to be plenty adequate, though you'll have to adjust this according to the light pollution and seeing conditions where you are, as well as your camera's capabilities. The narrowband filters all have longer exposures. Among narrowband filters, the HA tends to produce a brighter image, so its exposure time is only 12 seconds. The 03 filter is not nearly as bright, and its exposure time is 40 seconds. And the S2 filter above the 03 filter, well, anybody who's done any narrowband imaging knows how difficult S2 filters can be, and they require fairly bright stars to focus on, and even then, very long exposures. When I captured the screenshot, I was actually in the middle of calibrating my focus offset times, a topic I'll cover in a moment. But, in the end, to get my S2 filter to focus, even in the dark sky conditions where I live, I had to go with a gain of 130 and an exposure time of 60 seconds. The idea here is to find the shortest possible exposure time that you can for your camera, and your filters, and overall your particular setup and conditions. Now, of the various columns, we're not going to go into position nor name. They're simple enough. You just click on a filter's name and you can change it in Nina if you want. And the focus offset, well, that is dependent on your individual camera, and I don't really ever change that for autofocus purposes. And I think most modern cameras will just stick in their default or recommended offset right there. Now, offset is a complex topic and not one we're going to cover in this video. If you want to know more about it, we'll get to it eventually. So the next column to look at is the focus offset, and this column should not be confused with the offset column. The offset column adjusts the gain offset of your camera. The focus offset column adjusts the position of your electronic autofocuser. So, what focus offsets are, that's a little complex to explain. Each filter affects the light that passes through it a little differently, and therefore changes to some degree how that light focuses on your camera sensor. And that means you should do an autofocus every time you change filters. But with some filters, especially narrowband filters, that would be very time-consuming and you'd spend a great deal of your night just focusing. But you can work around this by determining a primary focus filter, usually the luminance filter. The luminance filter is an ideal filter for this because it lets almost all the light pass through it. So when autofocusing, it requires the shortest exposures. This means you can autofocus on the luminance filter fairly quickly. Once your EAF has focused on it and determined a focus position, when you move to a filter that requires a long exposure, such as a narrowband filter, your EAF can move to an offset based on the position of the primary filter. And this can and will reduce autofocusing time by a great deal. And time reduced from autofocusing can be used catching subs. Now for things like LRGB filters, this doesn't matter so much because they let a fair bit of light through under any circumstances and they tend to focus fairly quickly. In fact, as we talked about earlier, if you just adjust the gain for the RGB filters, they focus as quickly as the luminance filter. Though some persons may still prefer to use focus offsets even for LRGB filters. It depends on what kind of strategy you're using to catch your images, as well as what kind of strategy you want to apply to deal with changes in the atmosphere. For myself, when I film, I like to have my autofocuser refocus on LRGB filters every time I change one. And that's because in these northern skies, temperatures can change substantially through the night, having a significant impact on the focus. I lose a little exposure time that way, but I ensure sharp, clear images every morning. But for narrowband filters, which even the HA filter here in these dark skies takes 12 seconds to focus, and the O3 filter would take 40 seconds, and the S2 filter would take 60 seconds. That means the fastest narrowband autofocus sequence would take 120 seconds, plus about 2 more minutes for the time that it takes the focus motor to move and settling to occur, or 4 minutes per autofocus sequence on the HA filter. An O3 autofocus sequence would take almost 9 minutes, and an S2 autofocus sequence would take 12 minutes, and that's if it's successfully autofocused the first time. I find the S2 often has to repeat 2, 3, or 4 times. That would be a lot of time spent in autofocusing. In fact, half the night or more. On top of that, narrowband filters let so little light through that, unless there are very bright stars in the image, typically stars above magnitude 2, odds are good your narrowband filters would not be able to successfully autofocus anyway. So to use them, you really have to set up an offset system. So when it comes to narrowband, offsets are more than useful, they are necessities. So let's talk about how to go about setting up an offset system. It's not hard really, but I can virtually guarantee you when you actually have to do it, if you haven't done it before, you're going to find it vexing. Narrowband filters are unfortunately slow and tricky to focus. The way you figure out what your offsets are is have your system autofocus using your luminance filter, and then write down the position of the autofocus when the camera reaches focus. To find that position, go to the imaging page and look to the upper left if you're using a standard Nina Windows layout. There you'll see a small focuser window. In that window, in the 3rd row down, you'll see a row named Position. And on the right, you'll see the numeric value of your focuser's position. Let's pause here and put the next part in parentheses. You can designate any filter to be the filter upon which the other offsets are based. However, since autofocus on the luminance filter is the fastest, easiest, and most reliable, it's typically best to use your luminance filter as your baseline for your offsets. So, close parentheses and back to the topic. Then go to your fastest narrowband filter, this should typically be your HA, and have Nina run a focus sequence. If the sequence succeeds, record the numeric value of the autofocuser's position. Then do the same with your O3 filter, because it'll be the next fastest. When you're done, I suggest that you re-autofocus on your luminance filter, because in the 15 or 20 minutes it probably took to do that, your sky conditions might have changed a little bit, creating a slight difference in the focus setting, and then run an autofocus sequence on your S2 filter. This may take a while. S2 filters require long exposure times, and even then they can be tricky and finicky. But when you finally get a successful autofocus on your S2 filter, record its position too. You can then use the outcomes to calculate your offsets. Just subtract the numeric positions recorded for the narrowband filters at focus from the luminance filter at focus, and record the differences in the offsets. Be sure to designate if the difference is negative. Then click on the Options tab on the far left. In the next tab to the right, click on the Autofocus tab, and go back down to the Autofocus filter settings. On the Filter Offset column, enter the focus offset values for your HA, S2, and O3 filters. And with that done, you should have your focus offsets taken care of. But like I said, the explanation is easier than the actuality. Expect a little frustration while attempting to autofocus your narrowband filters, in particular the S2 filter. And remember, to help you autofocus those narrowband filters, get the brightest stars you can into your field, preferably magnitude 2 or above. Lift the gain to whatever your camera's unity gain is, and increase your exposure time to whatever is necessary to allow the narrowband filters enough time to gather enough light to achieve focus. The HA filter is the brightest, but it still could be double your luminance exposure time or more, and your S2 filter will typically be the darkest and could need exposure times in excess of 40 seconds. Like I said, for me to focus it, even in these very dark skies where I live, I needed 60 seconds of exposure time. If using Nina, you can tell Nina to use offsets or ignore them. If you use different strategies for focusing with different filters, that's important. For example, when I'm shooting LRGB, I autofocus every time the filter wheel changes to a different filter. But if shooting narrowband, I autofocus on the luminance filter, and then have Nina apply a focus offset to whatever narrowband filter I am using. In Nina, to turn your focus offsets on and off, just go to the Options tab on the far left, select the Autofocus tab in the column right beside it, And directly top left, just under the autofocus heading, you'll see the option Use Filter Offsets. Just click it on if you want to use your filter offsets and click it off not to. Okay, let's move on. Now many good modern filters are parfocal, meaning they are exactly, or more accurately, almost exactly, at the same focus position one to another. But it's rarely ever perfect. However, sometimes if there is a difference, it's so small it doesn't matter. For example, the ZWO LRGB filters that I'm using are advertised as parfocal, and I've run test focus sequences on them 4 times, and they are in fact parfocal. They are at most only a point or 2 off from each other, but that could easily just be an error in the measurement. 4 tests isn't that many, so I wouldn't call it an extremely reliable sample of focus variation, but I think it's accurate enough, and in tests I've tried, it works. They're parfocal enough. What this means is that if you determine that your filters are parfocal, and don't take the manufacturer's word for it, test them for yourself. Unfortunately, there is a history when it comes to filters of manufacturers making claims that haven't always borne out. But if your own testing shows that they are in fact parfocal, then you don't need to refocus those filters when you change to them. For example, if you're shooting RGB and focus on your luminance filter, you don't need to run another autofocus when you change to RGB. Now let's touch upon targets and autofocus. Some targets have a way of throwing off autofocusing, especially large hazy targets such as nebulae and galaxies. The one that I find to be the most troublesome is Andromeda, and if memory serves, it's about 6 times wider than the full moon. And from your autofocus perspective, it's just trying to focus on a big haze. So if you run into a target that really makes it difficult for you to autofocus, there is an easy solution. Just repoint your telescope very slightly off whatever the troublesome target is. Very slightly. You want to get it just out of frame. That way you aren't moving across so much sky that the atmospheric conditions will be much changed. When the troublesome target is out of the frame, go ahead and run autofocus again. This time on a clear sky and just focusing on stars, the EAF or electronic autofocuser should work just fine. Then slew back onto your target. Well, those are all my tips today for speeding up and improving your focusing process. If you have any thoughts, questions, or observations, please note them in the comments below. Have fun doing astrophotography and get out there and shoot the sky.